everyone remembers the small block Ford, the Windsor, the Cleveland. These were the engines that powered America through the muscle car era, the engines that defined what Ford performance meant for generations. But what if I told you that Ford's greatest engine achievement didn't happen in the 1960s or 70s? What if the most important V8 Ford ever built arrived in 1991, when muscle cars were supposed to be dead, when emissions regulations had strangled the life out of Detroit, and when computer chips were replacing carburetors? That engine was the Modular V8, and it didn't just redefine what Ford could do. It rewrote the rules for durability, longevity, and performance in ways that still echo through every highway and worksite across America today. This is the story of how an engine nobody wanted became the backbone of American industry. And that's where the story begins. By the late 1980s, Ford had a problem. Their legendary small block engines, variations of the Windsor design that dated back to 1962, were reaching the end of their evolutionary road. Emissions regulations were getting tighter every year. Fuel economy standards were climbing, and the American buying public, bruised by gas crises and economic uncertainty, wanted engines that would last longer than their car payments. The old pushrod designs, as brilliant as they had been, simply couldn't meet all these demands simultaneously. Ford needed something revolutionary. They needed an engine that could produce more power with less displacement, meet stricter emission standards, deliver better fuel economy, and most importantly, survive for hundreds of thousands of miles with minimal maintenance. That was a tall order in an era when most engines were considered worn out at 100,000 miles. The automotive landscape was changing rapidly, and Ford needed to change with it or risk becoming irrelevant in an increasingly competitive marketplace. The project began in 1985, deep inside Ford's Engineering and Research Center in Dearborn, Michigan. A team led by Chief Engineer Dick Godfrey received a mandate that seemed almost impossible. Design a completely new V8 engine family that could power everything from luxury sedans to heavy-duty trucks, that could last twice as long as existing engines, and that could adapt to future technologies nobody had even invented yet. They called it the modular engine because it was designed from the beginning to be flexible, adaptable, and scalable. The same basic architecture could be built in different displacements, with different cylinder heads, and for different applications. One engine platform, infinite possibilities. That was the vision. Making it reality would take 6 years and hundreds of millions of dollars. The team assembled for this project represented some of Ford's best engineering talent, pulled from various divisions and given the freedom to rethink everything about V8 engine design. The corporate environment at Ford during this period was complicated. The company was recovering from near bankruptcy in the early 1980s, and spending hundreds of millions on an entirely new engine program was a massive risk. But Ford's leadership understood that standing still was even riskier. Japanese manufacturers were gaining market share with engines that simply lasted longer than Detroit's offerings. European manufacturers were demonstrating that sophisticated overhead cam designs could deliver both performance and efficiency. Ford needed to compete on a global stage, and that meant building engines that could match or exceed anything the competition offered. The modular program represented Ford's commitment to that goal, even when the bean counters questioned every expenditure and every design decision. This wasn't just about building a new engine. This was about securing Ford's future in an industry that was leaving American manufacturers behind. The engineers started with a clean sheet of paper, which was both liberating and terrifying. They weren't constrained by existing tooling or manufacturing processes, but they also couldn't rely on decades of proven designs. Every decision had to be justified, tested, and validated. The first major choice was abandoning the traditional pushrod valve train that had defined American V8s since before World War II. Instead, the modular would use overhead camshafts, with the cams mounted directly in the cylinder heads. This wasn't a new technology. European manufacturers had been using overhead cams for decades, but it was new for Ford truck and car engines, and it represented a fundamental shift in philosophy. Overhead cams allowed for more precise valve timing, higher RPM capability, and better breathing. They also made the engine taller and more complex, which created packaging challenges. But the performance and efficiency benefits were undeniable. The decision to use overhead cams wasn't made lightly. It required convincing Ford's management that the added complexity and cost would pay dividends in performance, efficiency, and durability. The second major decision was block construction. The modular engine used a deep skirt block design, meaning the cylinder block extended well below the crankshaft's center line. This created an incredibly rigid structure that resisted flexing and twisting under load. Combined with cross-bolted main bearing caps on 4 bolts each instead of the traditional 2, the Modular's bottom end was built like a bridge, designed to handle enormous stress for hundreds of thousands of miles. The engineers knew that durability started with the foundation, and they overbuilt that foundation deliberately. The block was cast iron in truck applications and aluminum in performance applications, but the architecture remained the same: strength, rigidity, longevity. These weren't just marketing words. They were engineering mandates that guided every decision. The deep skirt design added weight and manufacturing complexity, but it created an engine that could withstand punishment that would destroy conventional designs. The bore and stroke dimensions were carefully calculated to balance power, efficiency, and durability. The original 4.6-liter version measured 3.55 inches bore by 3.54 inches stroke, creating an almost perfectly square engine that could rev freely while maintaining good low-end torque. This square design was intentional. Longer stroke engines produce more torque but can't rev as high due to increased piston speed. Shorter stroke, larger bore engines can rev higher but sacrifice low-end grunt. The Modular's square dimensions split the difference, creating an engine that could deliver usable power across a broad RPM range. Later variations would include 5.4-liter and 5.0-liter versions, all sharing the same basic architecture but scaled for different applications. This modularity meant Ford could use the same manufacturing equipment, the same engineering expertise, and the same parts supply chain across multiple engine sizes. It was efficient, it was smart, and it saved Ford millions in development and production costs, while ensuring consistent quality across the entire engine family. The cylinder heads were a revelation. Instead of simple 2-valve designs, the Modular used either single overhead cam with 2 valves per cylinder or dual overhead cam with 4 valves per cylinder depending on the application. The 4-valve heads, called 4.6 DOHC, featured individual camshafts for intake and exhaust valves, allowing for incredibly precise control over valve timing and duration. The combustion chambers were designed using computer modeling, a relatively new technology in the late 1980s. And the result was a chamber shape that promoted complete burning of the air-fuel mixture while minimizing emissions. Every aspect of the design was optimized not just for power, but for efficiency and longevity. The valve springs were carefully selected to provide adequate tension without causing excessive wear. The cam profiles were ground to specifications that balanced performance with durability. Even the valve stem seals were engineered to last hundreds of thousands of miles without leaking. Ford's metallurgists spent countless hours selecting materials that could withstand extreme temperatures and pressures while maintaining dimensional stability over decades of use. But that was only the beginning. The modular engine needed to survive in the real world, not just on a computer screen or test stand. Ford subjected prototypes to torture testing that would have destroyed lesser designs. They ran engines at maximum RPM for days at a time. They cycled them between freezing cold and desert heat. They simulated 250,000 miles of driving in climate-controlled chambers, then tore the engines down to measure wear. The results were remarkable. Even after simulated abuse that represented decades of hard driving, the modular engines showed minimal wear on critical components. The overbuilt bottom end, the rigid block structure, and the carefully selected bearing materials all contributed to durability that exceeded Ford's already ambitious targets. Engineers found that the deep skirt block design reduced harmonic vibrations that could cause fatigue failures. The cross-bolted main caps prevented the microscopic movement that led to bearing wear in older designs. The overhead cam setup reduced the number of moving parts in the valve train, which meant fewer components to wear out or fail. The oiling system received special attention. Ford engineers knew that proper lubrication was critical to long-term durability. So they designed an oil pump and distribution system that could maintain pressure under extreme conditions. The pump was gear-driven directly from the crankshaft, ensuring consistent oil pressure at any engine speed. The oil passages in the block were carefully sized and positioned to deliver adequate flow to all bearings and moving parts, without creating excessive pressure that could cause seal failures. The oil filter was positioned for easy access, encouraging regular maintenance. Even the oil pan was designed with baffles to prevent oil starvation during hard cornering or acceleration. These weren't glamorous features. Nobody bought a car because it had well-baffled oil pan. But these details, multiplied across hundreds of components, created an engine that could survive when others failed. The engineering team understood that durability wasn't about one brilliant innovation. It was about getting 1,000 small details right and ensuring they all worked together harmoniously. The first production Modular V8 rolled off the assembly line in 1990 for the 1991 model year, destined for the Lincoln Town Car. This was a deliberate choice. Ford wanted to introduce the new engine in a luxury application, where refinement and reliability mattered more than raw power. The Town Car's 4.6-liter single overhead cam version produced 190 horsepower and 260 foot-pounds of torque. Those numbers weren't earth-shattering, but they represented only the beginning of what the modular platform could achieve. More importantly, the engine was smooth, quiet, and efficient, delivering better fuel economy than the old Windsor V8 it replaced while meeting stringent emission standards that the older engine couldn't touch. Lincoln buyers, accustomed to silky smooth V8s that whispered rather than roared, found the modular to be a worthy successor. The engine's inherent balance, courtesy of its overhead cam design and careful engineering, meant less vibration at idle and smoother power delivery across the RPM range. Town car owners reported that the new engine felt more refined than the Windsor, with less noise and vibration intruding into the luxury cabin. The Crown Victoria and Grand Marquis received the Modular in 1992, bringing the new engine to Ford's full-size sedan lineup. These cars would become the ultimate proving ground for modular durability. Police departments across America ordered thousands of Crown Victorias equipped with the 4.6 SOHC, and these cruisers would rack up miles in the most punishing conditions imaginable. High-speed pursuits, extended idle periods with all accessories running, stop-and-go urban traffic. These engines endured it all. Stories began circulating about police cruisers exceeding 300,000 miles with nothing more than routine oil changes and occasional spark plug replacements. Taxi companies took notice. New York City's yellow cab fleet, which had traditionally favored Chevrolet Caprices, started switching to Crown Victorias because the modular engines simply lasted longer. Cab drivers who put 100,000 miles a year on their vehicles found that the modular could handle that abuse year after year without major repairs. These real-world applications provided validation that no amount of laboratory testing could match. Then came the breakthrough that would change everything. In 1993, Ford dropped the modular into the Mustang GT, and suddenly this sophisticated, smooth-running luxury car engine had to prove it could satisfy performance enthusiasts raised on small block thunder. The 4.6 SOHC made 215 horsepower in Mustang trim, which was respectable but not revolutionary. Critics complained about the lack of low-end torque compared to the old 5.0 Windsor. They said the engine was too tall, too heavy, too complex. The modular was about 75 pounds heavier than the Windsor it replaced, and that weight sat higher in the engine bay due to the overhead cam design. Enthusiasts mourned the loss of the Windsor's simplicity and aftermarket support, but Ford was playing a long game. They knew the modular's overhead cam design had performance potential the old pushrod engines could never match. They just needed time to unlock it. The performance community remained skeptical, but Ford's engineers understood that building credibility with enthusiasts would require more than words. It would require performance that couldn't be denied. That time came in 1996 when Ford introduced the 4.6 DOHC version in the Mustang Cobra. With dual overhead cams, 4 valves per cylinder, and more aggressive tuning, the DOHC made 305 horsepower. Suddenly, the critics went quiet. This was serious power from a naturally aspirated engine, and it delivered that power with a top-end rush that felt more like a European exotic than a Detroit muscle car. The DOHC modular could rev to 6,800 RPM safely and smoothly, breathing through those 4 valves per cylinder with an efficiency that left pushrod engines gasping. The power delivery was intoxicating. Below 4,000 RPM, the DOHC felt strong but not overwhelming. Above that threshold, it came alive, pulling harder and harder until the rev limiter intervened. Ford had proven the modular wasn't just durable, it was fast. And more importantly, it could be both simultaneously. The Cobra became a halo car for the modular platform, demonstrating that overhead cam technology could deliver the performance American enthusiasts demanded. But the modular's real proving ground wasn't drag strips or road courses. It was Main Street America. in millions of work trucks, police cruisers, taxicabs, and family sedans that accumulated miles by the hundreds of thousands. The 4.6-liter and 5.4-liter versions became the standard power plants in Ford's F-Series trucks starting in 1997, and that's where the durability engineering really paid off. These engines hauled loads, towed trailers, and ran at wide-open throttle in conditions that would have killed older designs. And they kept running. 200,000 miles became common, 300,000 wasn't unusual. Reports of modular engines exceeding 500,000 miles started filtering in from taxi fleets and delivery companies. The overhead cam design meant fewer reciprocating parts and less stress on the valve train. The rigid block structure prevented the flexing and distortion that caused premature bearing wear. The carefully engineered oiling system kept critical components lubricated even under extreme angles and loads. Construction workers discovered that F-Series trucks with modular engines could survive job site abuse that destroyed lesser vehicles. These trucks spent their days hauling maximum payloads over rough terrain, idling for hours while running power tools off the alternator, and towing heavy trailers through mountain passes. The modular engines absorbed that punishment without complaint. Farmers found that Super Duty trucks with 5.4-liter engines could pull loaded grain trailers, power hydraulic systems, and run all day in dusty field conditions. The air filtration system Ford designed for truck applications kept dust and debris out of the intake, and the robust construction meant the engines could survive occasional maintenance, neglect that would have caused problems in more delicate designs. Landscaping companies, delivery services, and contractors all discovered that Ford trucks with modular engines represented excellent value because the engines would outlast everything else on the vehicle. Ford's engineers had built something special, and the American public was starting to notice. The modular wasn't flashy. It didn't have the romance of a vintage small block or the exotic appeal of a European engine. But it worked, day after day, year after year, mile after mile. It was the engine equivalent of a workhorse that never complained, never quit, and never asked for anything more than regular oil changes and basic maintenance. Police departments loved them because Crown Victoria cruisers with modular V8s would run for 300,000 miles of hard pursuit, driving in high idle hours. The engines could survive the thermal cycling of repeated high-speed runs, followed by extended idling. They could handle the electrical loads of modern police equipment without the alternator-driven accessories causing premature wear. Taxi companies loved them because the same Crown Victorias could survive New York City traffic for years, with drivers who treated maintenance as an afterthought and drove like every trip was a NASCAR race. Construction companies loved them because F-Series trucks with modular engines would haul loads and tow trailers long after the body and frame showed serious wear. The engine became the most reliable component in these vehicles, outlasting transmissions, suspensions, and body panels. The performance applications kept evolving too. In 1999, Ford introduced the 4.6 DOHC in the Lincoln Navigator, and suddenly luxury SUV buyers discovered what serious power felt like in a 5,000-pound vehicle. The supercharged version in the 2003 Mustang Cobra pushed 390 horsepower, proving the modular could handle forced induction with the same reliability it demonstrated in naturally aspirated form. That supercharged engine was a revelation. The Eaton supercharger, mounted on top of the engine and driven by the crankshaft, provided instant boost with none of the lag associated with turbochargers. The result was an engine that delivered massive torque from idle to redline, capable of launching the Cobra from 0 to 60 in under 5 seconds. Ford had carefully engineered the internals to handle the additional stress of supercharging. Stronger pistons, upgraded connecting rods, and improved head gaskets ensured the engine could survive sustained boost without failure. Owners reported that even with the added stress of forced induction, the supercharged modulars proved just as durable as their naturally aspirated siblings. The 5.4-liter version, introduced in 1997, became the workhorse of Ford's truck line, producing anywhere from 130 to 310 horsepower, depending on application and year. That bigger displacement brought more torque, and torque is what moves loaded trucks and tows heavy trailers. The 5.4 became legendary in its own right, powering millions of F-150s and Super Duties through decades of hard work. The engine's 281 cubic inches of displacement, achieved through a longer stroke than the 4.6, created a power band perfectly suited to truck applications. Maximum torque arrived at relatively low RPM, meaning the engine pulled strong from idle without requiring downshifts to access power. Towing a 10,000-pound trailer through the Rocky Mountains, the 5.4 would maintain highway speeds without overheating or losing power. The cooling system Ford engineered for truck applications featured larger radiators and more robust water pumps designed to handle sustained high-load operation. RV owners particularly appreciated the 5.4, finding that it provided adequate power for towing large trailers while maintaining reliability over hundreds of thousands of miles. But the Modular's greatest achievement might have been what it did for Ford's reputation. For years, American manufacturers had been criticized for building engines that couldn't match the reliability of Japanese and European designs. Honda's engines routinely exceeded 200,000 miles. BMW's inline sixes were legendary for durability. Mercedes-Benz diesels could accumulate 500,000 miles. Detroit had a perception problem, and the Modular helped solve it. Here was an American engine that could outlast anything from overseas, that delivered modern performance and efficiency while maintaining old-school durability. It proved that Detroit could innovate, could adopt new technologies, and could build engines that would survive into the next century. The Modular wasn't just an engine. It was a statement, a declaration that American engineering still mattered, still excelled, and still set standards the rest of the world had to follow. Consumer Reports, historically critical of American automotive reliability, began giving Crown Victorias and F-Series trucks higher reliability ratings based largely on modular engine durability. J.D. Power surveys showed owner satisfaction with modular-powered vehicles exceeding expectations. These weren't subjective opinions. These were data-driven assessments based on hundreds of thousands of real-world experiences. The Modular had changed the conversation about American engine reliability. Automotive journalists who had spent years praising Japanese reliability and criticizing Detroit suddenly found themselves writing about Ford engines that could match or exceed anything from overseas. The tide was turning, and the Modular was leading that change. The racing world took notice, too. NASCAR teams discovered the Modular could be built to survive 500 miles at wide-open throttle while producing over 700 horsepower. The deep skirt block design and overbuilt bottom end translated perfectly to racing applications. Ford's success in NASCAR during the 2000s owed much to the Modular platform's inherent strength and reliability. Teams could push these engines to limits that would have destroyed traditional pushrod designs, and the Modulars would survive race after race. Drag racers found that the DOHC version could make 4-digit horsepower with forced induction, and the rigid block structure meant that power didn't grenade the engine after a few runs. The Modular became a favorite among engine builders who appreciated how the platform responded to modification while maintaining the durability that made it famous. Aftermarket companies developed entire product lines around the Modular platform, offering everything from performance camshafts to forged internals to custom cylinder heads. The performance potential that Ford's engineers had designed into the platform was being realized in ways they never imagined. The 5.0 Coyote engine, introduced in 2011, represented the ultimate evolution of the Modular concept. While technically a different engine family, the Coyote inherited the Modular's DOHC architecture, rigid block design, and durability-focused engineering. With 412 horsepower in stock form and the ability to rev to 7,000 RPM, the Coyote proved that Ford's overhead cam V8 philosophy had reached full maturity. The Coyote engines have proven just as durable as their Modular predecessors, while delivering performance that would have seemed impossible when the first 4.6 town car engine rolled off the line in 1991. The Coyote benefited from lessons learned over 2 decades of Modular production. Engineers refined the oiling system, optimized the combustion chamber design, and reduced internal friction through careful material selection and surface treatments. The Coyote represented everything Ford had learned about building durable, high-performance overhead cam V8s, and it demonstrated that the Modular program's influence would extend far beyond its own production run. Throughout its production run from 1991 to 2014, the Modular V8 powered over 25 million Ford vehicles. That's 25 million engines built on the same basic architecture, sharing the same core engineering principles. delivering reliable service across every corner of America and beyond. Some of those engines went into luxury cars that barely saw hard driving. Others went into work trucks that lived at maximum load. Some powered police cruisers through high-speed pursuits. Others hauled families on cross-country vacations. But they all shared one characteristic: they kept running. The Modular's legacy isn't measured in horsepower numbers or 0 to 60 times. It's measured in millions of Americans who drove their vehicles past 200,000 miles and never thought twice about engine reliability. It's measured in businesses that built their operations around trucks they knew would last. It's measured in police departments that could budget for vehicle replacement based on body wear rather than engine failure. The economic impact of that reliability is difficult to quantify, but it saved American businesses and consumers billions of dollars in reduced maintenance costs and extended vehicle life. But nothing in Detroit lasts forever. By the early 2010s, Ford was developing the EcoBoost engine family, turbocharged V6s that could match the Modular's power while delivering better fuel economy. The 3.5-liter EcoBoost, producing 365 horsepower, could outperform the 5.4-liter Modular while achieving significantly better fuel economy. Emissions regulations and corporate average fuel economy standards, called CAFE, were pushing manufacturers towards smaller turbocharged engines. The Modular, for all its sophistication and durability, was still a relatively large, heavy V8 in an era when efficiency trumped displacement. The F-Series trucks that had been powered by Modular engines since 1997 switched to EcoBoost V6s for their volume models. The Mustang got the Coyote, which was technically a new design. The Crown Victoria, the last bastion of 4.6 SOHC production, was discontinued after 2011. The Modular era was ending, not because the engines had failed, but because the world had moved on. Customer priorities had shifted from pure durability to a balance of durability, performance, and efficiency, and newer technologies could deliver that balance more effectively. The final Modular V8 rolled off the assembly line in 2014, marking the end of a 23-year production run that had redefined what American engines could achieve. There were no fanfare or ceremonies, no special editions or commemorative plaques. The Modular simply stopped being produced because Ford had moved on to newer technologies. But that quiet ending was somehow appropriate for an engine that had never been about flash or spectacle. The Modular was always about substance, about doing the job, about lasting longer than anyone expected, about proving that American engineering could still build something that would survive when everything else around it wore out. The engineers who had spent decades refining and improving the Modular platform moved on to new projects, carrying with them the lessons learned from one of the most successful engine programs in automotive history. Today, Modular V8s are everywhere. They're in work trucks with 400,000 miles that still start every morning. They're in restored Mustang Cobras that dominate weekend track days. They're in police cruiser auctions with odometers showing 300,000 miles of hard service and engines that still purr. They're in junkyards, being pulled for rebuilds and swaps, because even worn-out Modulars have value. The engine community has embraced the platform, developing aftermarket support that rivals classic small blocks. You can build a 4.6 DOHC to make 1,000 horsepower. You can rebuild a 5.4 with upgraded components and have an engine that will outlast the vehicle it's installed in. The knowledge base is extensive, the parts availability is excellent, and the platform's versatility means there's always something new to discover. Engine builders have learned that the Modular platform responds exceptionally well to forced induction. The strong block and robust bottom end can handle substantial boost pressure with minimal modifications. Naturally aspirated builds can exceed 500 horsepower with the right combination of heads, camshafts, and intake systems. The DOHC version's 4-valve design provides excellent airflow potential, and aftermarket cylinder heads can push that potential even further. Tuners have developed sophisticated calibrations that extract every bit of performance while maintaining reliability. The Modular has become a favorite for engine swaps, with enthusiasts installing these engines in everything from vintage Mustangs to hot rods to kit cars. The engine's relatively compact width and readily available transmission options make it an attractive choice for custom applications. The Modular's influence extends beyond just the engines themselves. Ford's commitment to overhead cam V8 technology, born with the Modular program, continues in the Coyote and its successors. The engineering philosophy of overbuilding critical components, of designing for longevity rather than just initial cost, became embedded in Ford's corporate culture. The modular proved that sophisticated doesn't mean fragile, that modern doesn't mean disposable, and that American manufacturers could build engines that would survive in an increasingly competitive global market. Those lessons shaped everything Ford built afterward. When engineers designed the EcoBoost engines, they incorporated durability lessons learned from modular development. When Ford developed new transmission technologies, they considered how those transmissions would mate with engines designed to last 300,000 miles or more. The modular's influence can be seen in every Ford powertrain developed since, a testament to the enduring value of the engineering principles it embodied. Walk through any American town today, and you'll see modular-powered vehicles still working, still serving, still doing what they were designed to do. That F-150 hauling lumber has a 5.4 with 300,000 miles. That restored Lincoln Town Car gliding down Main Street has a 4.6 SOHC that runs as smoothly as the day it was built. That Mustang GT sitting in the high school parking lot has a 4.6 that's teaching another generation what reliable performance means. The Modular V8 didn't have the sex appeal of the engines that came before it. It didn't inspire songs or movies. It didn't have a cool nickname that rolled off the tongue. But it did something more important. It worked, and it kept working. And 30 years later, it's still working. Mechanics who service these engines report that properly maintained modulars can reach 500,000 miles without major internal work. The overhead cam design that critics initially questioned has proven remarkably durable, with cam wear being virtually non-existent when regular oil changes are performed. The Modular V8 wasn't supposed to be legendary. It was supposed to be practical, efficient, and durable. It was supposed to meet emission standards, deliver decent fuel economy, and last longer than previous engines. By those modest goals, it succeeded beyond anyone's wildest expectations. But somewhere along the way, something unexpected happened. This engine that nobody wanted, this sophisticated overhead cam design that enthusiasts initially rejected, this platform that seemed too modern and too complex, became the backbone of Ford's success for nearly a quarter century. It proved that doing things right matters more than doing things quickly. It proved that engineering for longevity creates value that transcends initial cost. It proved that sometimes the most important innovations aren't the ones that get headlines. They're the ones that still work when everything else has failed. That's the legacy of Ford's Modular V8. Not the most powerful, not the most efficient, not the most sophisticated by modern standards, but possibly the most durable, most reliable, most unappreciated engine ever to come out of Detroit. An engine that redefined what Americans could expect from their vehicles, that raised the bar for reliability so high that competitors had to scramble to catch up. And that proved American engineering still had something important to say in an era when everyone assumed the future belonged to someone else. The Modular demonstrated that patience and proper engineering could create products that delivered value for decades. It showed that sometimes the boring answer, the methodical approach, the decision to overbuild rather than optimize for initial cost, produces results that transcend quarterly earnings reports and become genuine contributions to American industrial capability. Have you ever owned a vehicle with a Modular V8? Did you drive that Crown Victoria taxicab through New York traffic for 5 years straight? Did you tow your fifth wheel across America behind an F-250 with a 5.4 that never complained? Did you feel that DOHC Cobra wind up to 7,000 RPM and realize Ford had built something special? Share your stories in the comments. Tell us about the miles you've logged, the loads you've hauled, and the memories you've made with these engines. And if you enjoyed this story about an engine that changed everything by simply refusing to quit, hit that subscribe button for more forgotten American legends that shaped our automotive world. Because the best stories aren't always about the fastest or the flashiest. Sometimes they're about the machines that just kept running, year after year, mile after mile, long after everyone else had given up.